welcome to the Data Engineering Podcast, the show about modern data infrastructure. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at www.dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. Go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. And to help support the show, you can check out the Patreon page, which is linked from the site. To help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. This is your host, Tobias Macey, and today I'm interviewing Ry Walker, CEO of Astronomer, a platform for data engineering. So, Ry, could you please introduce yourself?
Sure, yeah. Hi. Glad to be on the podcast. Ry Walker, CEO of Astronomer. We're a 2-year-old data engineering platform that we've been working on, and I'm a lifelong entrepreneur. This is my 4th company of substance. I've been doing this stuff for a long time, but a few years ago kind of got hooked on the whole data revolution, the data science trend, and decided to build a company in the space. We're pretty excited about what we're doing.
And how did you first get involved in the area of data management, and what is it that interests you about it?
We were working on a product called User Cycle. We actually took that over from somebody, a friend of mine, and basically discovered that the biggest challenge in the business was not so much making a sale or explaining the value prop. It was a product analytics company, similar to like Mixpanel or Kissmetrics, things like that. But the biggest challenge was getting companies to hook their data up to us. Our product could do nothing without data being fed to it. So, we spent a lot of time trying to, we said you guys should use Segment. We built an integration with Segment so that it was easy to get the data to us that way, but not everyone wanted to use Segment. And just realized that, at the time, I think there were 3,000 tools in that like marketing tools chart. I don't know if you've seen that on the internet, but we figured like every company in our space had to be having the exact same challenge because there was nothing special about our situation. And so, we pivoted away from building an analytics product to building a company that helped organizations wield their data, for their own benefit.
And so that company, I'm assuming, is Astronomer. So I'm wondering if you can give a sort of high-level overview about what Astronomer is and some of the origin story.
It was kind of funny. We were at a conference, the Collision Conference in Las Vegas a couple of years ago, and I think it was May 20th. It's funny, I know the exact date because it was a password I used for a while, the date where we pivoted. But we went to that conference on day one, and we were User Cycle. We weren't feeling it. It was for the first time kind of out, like talking about the product in mass. And that evening, actually during the conference, there were a lot of DevOps, and dev tool, selling to devs, kind of a lot of stuff like that going on in the world. So we decided to pivot that night and come back the next day as this other company, which we had been thinking about but hadn't pulled the trigger on. So we went back. I had some meetings with VCs the second day, and so that day, instead of talking about User Cycle, we talked about the new thing, and it was it was a way more timely product. I know this isn't a podcast about startups, but one of the things you generally learn is that the idea that you may have had initially is already played out in the world of venture capital. So you have to go somewhere a little bit more on the edge. And data engineering is still a pretty young discipline. Most people don't know the term, and so even today, it's just now I think coming into a little bit more understanding on what it is.
Yeah, a lot of people tend to still question, what is data engineering, and don't you mean data science, because that's sort of the hot buzzword of the moment and everybody knows what that is. But when they hear data engineering, it's sort of a little bit more of a nebulous concept to them, particularly because of the fact that data is so intangible in so many ways, and trying to understand how that pertains to an engineering discipline in and of itself is maybe a little bit foreign to them.
So like now, I built a web development company back in '95. This is like really early. I'd walk around downtown Cincinnati, the city I'm in, and we would unplug people's fax machines and show them the internet and say, do you want to buy a website? And they'd say, please plug my fax machine back in. Got important faxes coming in, and we're kind of in the same situation again. We're walking, we go to these big companies in the middle of the country, and basically try to explain to them, you have 40 analysts, or let's say you're talking to an insurance company, and they have hundreds of people who are using their company's data every day. and it's in a really bad form. It's like in a very hard to use format, and explain, you should add a layer of developers to make this data better for your people. And it's just a foreign concept, but we're doing our best to educate and teach people what's going on in this space.
And do you find that you have a difficult time getting people on board to using a hosted platform for managing and processing their data, particularly because of the sort of inherent value that their data has, though some companies might not necessarily realize the value that is contained within the information that they're gathering?
Yeah, I'd say there's definitely some resistance to that. Our platform is a little bit, some features that we don't really talk too much about on the website yet, that they're still kind of new, but you can actually deploy a VPC through our platform that has, that's essentially private network to their network. So we also have VPN capability. So, and basically, at the end of the day, if you want to send your data out into the world, it has to get out into the world at some point. And I think these, companies that live in a castle where all their data never gets to leave their premise are really playing at a disadvantage compared to technology companies that are trying to unseat them. So I tell them that about all the time. It's like, you're either going to evolve or die. It's digital Darwinism. And, most of them have tried doing some cloud things. So I'd say, especially like here in 2017 compared to 2015, the guards are coming down a lot to doing things, especially if it's like, for example, we deal with clickstream data or consuming data from the cloud. Obviously, it has that has to be connected to the cloud in some way in order to get the data. So, but we've got certain features in our product that help to alleviate some of those concerns.
And some companies are going to be dealing with data that has regulatory issues associated with it, such as HIPAA or FERPA or SOX compliance or PCI. So I'm wondering if there are any challenges associated with being able to properly secure the environments that those customers' data are flowing through. Do you have to segregate your network in order to make sure that their information doesn't contaminate somebody else's, or any other sort of special technical problems that come about from that kind of a situation?
We avoided any HIPAA and type deals early on because we just didn't want to deal with the headache. But our platform actually can be deployed completely on-prem as well. So we built it from day zero, knowing that just having it be a pure SaaS company would really limit our ability to work with larger businesses. So we built it from so it's that kind of gets into some of the architecture stuff, but we built it on top of DCOS, Apache Mesos, so that it was very portable and would run anywhere. We also early on we kind of built in some AWS dependencies that we're now removing, but the vision is that this thing is completely based on open source components that makes it easy to move around.
And that was actually one of the other issues I wanted to bring up. Is a lot of companies, when they hear the idea of open sourcing your core platform, they get sort of allergic to the concept. So I'm wondering, when you're in that kind of a situation where all of the pieces of your technical product can be obtained essentially free of charge, what's the motivation for somebody to actually pay you, and what are the differentiators that you have at that point that somebody won't necessarily be able to just replicate in-house without having a motivation to want to actually continue paying any sort of subscription cost or something like that?
Yeah, it's definitely a concern. It basically, and the fact that we're building this thing so that it's so it's sort of more dynamic than what you would build yourself. So, like, for example, our platform uses Apache Airflow, and we have to figure out ways to essentially generate pipelines based on configuration, let's say, where if you're just building it for yourself internally, you can literally just like drop a Python file in there as the thing. So it's definitely more complicated the way we're doing it. But I would just point to the fact that if you're going to do that, if you're going to try to bring Airflow in-house and Kafka in-house and Spark in-house and all the stuff that's inside of our platform, plan on hiring some people to manage that, to learn and manage that stuff. It's not like, those, I'm assuming you've at least played around with those tools. They're not small. They have a lot of surface area to learn and a lot of management to keep them up and running. So that's our argument is, yes, you could pull all these open source tools off the shelf. Go ahead and give that a shot. Give yourself 3 to 6 months and see how far you get. And we'll talk to you in 3 to 6 months, and you'll not make as much progress as you thought you would in general, unless you have some superstar developers, which again, a lot of the kind of companies we're talking to, they don't have those guys. They don't have those people in-house.
Right. The old axiom that open source is only free if your time is worth nothing.
Oh, yeah, I haven't heard that before. That's a good one. I'll definitely use that.
And is there a particular sort of size or scope of company that you find tends to actually have the dedicated resource for data engineering versus just having some developers or infrastructure people who are doing double duty for managing the company's data as well as their primary responsibilities?
Yeah, I mean, I think most data engineers are non-professionals, like data scientists. Obviously, if they know a little bit of R and Python, they can write some code to pipeline some data. Our experience is companies are either using tools like Microsoft SSIS or Dell Boomi or Alteryx, various ETL type technologies, or they're doing nothing. But it depends on what type of company we're talking about. In startups, they'll obviously write scripts and run them under cron, and that can kind of get you a certain way. But I think that the argument we make is all companies of any sort of substance, if you have a data scientist, you probably ought to have a data engineer sitting next to them, or else the data scientist is going to spend half their time doing data engineering.
And so I'm wondering if you can dig a bit deeper into what your data pipelining architecture actually looks like. You mentioned a few of the different components, but as you also said, there are some sort of special configurations that you're using in order to be able to make it more general purpose. And as anybody who's tried to open source a project before has noted, it's a lot more difficult to make something general purpose than it is to just use it for a specific use case.
Yeah, and so, our platform sort of starts with Mesos at the lower level, and we use Marathon, and we're using Prometheus and Grafana back on to do the kind of the instance level monitoring, Terraform to deploy. If I would say probably Airflow is the center point to a lot of what we're doing, but we deal with both streaming data as well as batch jobs, and I actually think the lines are blurring a bit between real time and batch because, for example, like you can take a real time. We're basically taking batch data and throwing it onto a Kafka queue sometimes, and then pulling that off in real time. So as data is being processed, let's say from a CSV download, you kind of turn into real-time data. That's an option instead of just dealing with it batch. And then at the same time, like real-time data is oftentimes, like if you want to push data into Redshift, you want to use the Redshift's copy command, which means you have to micro batch it. So it's kind of interesting, like that we're turning batch data into real time, and then turn it back into micro batch. So anyway, Kafka is pretty important. Spark is pretty important in our platform. Then we have our monitoring, our front-end monitoring stuff. So we push all the logs for everything into Elasticsearch, Logstash, and Kibana. Gosh, what am I missing? Our front-end app is React. We're using GraphQL for our API. So we're going to try to get by with our only API being a GraphQL API. I don't know if you saw, like, GitHub recently released their GraphQL API, so we'll have some nice docs around that. And, we're definitely an API-first sort of company, so anything that can happen in the system, we want to be accessible through that API. I think that's about it. I think those are the main components. And we have a bunch of different databases like Postgres and Mongo and Redis and stuff supporting that. One of the new things we're playing around with is I think we're going to put a time series database in there. I understand Druid's going to be the thing we try, and we're looking at Ceph for data storage. So there's all kinds of fun little mini projects in there for our infrastructure team, but we're kind of in this no Hadoop sort of mindset. So our platform doesn't really do any permanent storage, doesn't really do any data science, so there's no magical algorithms that happen in there. But I guess the final piece to it is our own open source connector library, which we call Aries. It's just various SaaS and database, source connectors and destination connectors. So that's the stack we're rolling. Does that sound like a lot?
Yeah, I mean, as you sort of dig down deeper into any technology company, at a high level, you think, there's just a few different components, and then as you dig deeper and deeper, you start uncovering more bits and pieces. Where I'm working, my primary responsibility is hosting the edX platform, and so you think, it's just a Django web app and a couple of databases, and it's like, I also have SaltStack to manage all the infrastructure, and then I've got Console for service discovery, and Vault for managing all the secrets, and then RabbitMQ for all the task management, and then I've got the Elastic File Store for permanent storage of data. So yeah,
we have Vault in ours too. I forgot about that. So
yeah, it's amazing how fractal these things become.
Yeah, and that's where I think it gets challenging. So again, like yeah, you can spin up a Airflow thing and get Spark running, and you have a couple of the components. But the other thing that we're trying to do is, so we're building these recipes. So like I don't know how many data engineers in this world have built let's get our data out of Salesforce and put it into our warehouse before. I imagine that's been built 50,000 times, let's say. And I think that's too many, So our theory is let's build a library of recipes of kind of standard best practices. And I understand maybe there needs to be 10 standard, Salesforce to warehouse recipes. But I just think it's horrible that we all have to build everything from scratch, go back to the root, the API docs and try to figure out what's the API providing me. And so, that's a big part of the next phase of our business is open sourcing this library of recipes that live on top of our platform that could be used even without our platform. But, the easiest way to use them would be there. And then we'll also hook our front end up to those recipes as well. So that if you just basically want to grab Salesforce data using recipe number 4, you should be able to just pull it off the shelf, provide your credentials and say go and let that stuff flow. If you want to tweak it, fork the recipe, upload that, and run a forked version of it. So I don't know if you've seen any systems like that, but that's the vision for what we're up to. Is we just think that if there's just one little transform you want to do in the middle that's different than the standard, let's put a little spot for that, so that maybe you can just define a mapper function of sorts. But yeah, basically we want to make the simple things almost invisible and the hard things possible. So we're going to let you run any Python in the pipeline, and we're using, because we're using Mesos, and we have these Dockers obviously super involved too. So every time a task starts in our world, it actually fires up a whole Docker container to run that task and then shuts it down. So it's pretty cool the way we're dealing with resource isolation.
Yeah, whenever you get into the point of having plugins to, map one input to another output, there's always certain complexities involved. So I'm wondering if you're using something like the adapter pattern, where you have a sort of standard data format or representation of the data within the core of your system, and then you use adapters to translate to and from that common representation to get from the source to the destination.
Yeah, in Clickstream, there's definitely some standard formats. A lot of different. So I'd say not quite so much yet. I could see that being a big issue that we have. There should be ought to be standard formats for various types of data, but we haven't quite dug deep into that so much. Everything is basically, we say collecting data. It should be simple, getting just the raw data into your database, and it just comes in whatever format the vendor provides the data basically. But that's our next challenge, is to help basically do some, call it pre-processing, or it's more like post-processing. After the raw data arrives, what can we do to make it immediately more usable than just having all the pile of raw data in there? So, but our platform is essentially infinitely wide because there's so many different areas and types of domain. So to the extent we cannot be the subject matter expert there, we'd love not to be. We want to be the kind of infrastructure for all this, and hopefully let communities manage what the standards ought to be.
And taking a brief aside, earlier when you were describing your architecture, you made a brief allusion to your infrastructure team. And one of the conversations that I had with Maxime Boschman previous episode was the idea of segregating your data engineering between the data infrastructure and then the actual people who are doing the engineering on the specific data. So I'm wondering what your perspective is on that particular divide, and I guess at what point that division actually happens in terms of overall scale of an operation.
Yeah, so we have 4 teams of engineers in Astronomer, which sounds like a lot considering we're an early stage startup, but I'll just describe that. And I think one of them, it would, most companies wouldn't need, but we have we call it the infrastructure team, and they're dealing with basically Mesos and all the services, deployments, and all that kind of stuff. Then we've got what we call the processing team. So these are people who, if you need to build apps that pull data from Kafka and do something with that, that's kind of the level that these guys work at. And then we have our front end team, which I think most companies don't need to build a front end to their data infrastructure. However, even Airbnb, obviously they've got all those pretty, they've got a lot of cool front end tools. And if you want to make these things accessible to to your people in the organization, you have to sort of think about that kind of stuff. And then finally, we have what we call the implementation team that actually builds pipelines on top of all this stuff. So, and they generally work on our customer organization. So they're engineers that are just doing customer specific work. So I think if I was designing a data engineering team, obviously I would say don't mess around. Like, I would start with people who build pipelines for one, and use a platform like us, that could be productive. But I think it's a big investment. I think if you're going to go like we're actually talking to some companies about helping them bootstrap a data engineering organization within their business. And I say, plan to hire 5 to 10 people to have enough mass, for this thing to feel worthwhile. If you're a company with 3,000 employees, a 10-person team is nothing, right?
And as you're growing the team at Astronomer and growing the platform, I know that from personal experience, a lot of these sort of technical platforms tend to have an organic evolution to them, which leads to technical debt. And so I'm wondering, what are some of the biggest sources of debt accrual that you're seeing in your particular platform, and some of the techniques that you're using to mitigate it?
Yeah, I mean, for sure, we built the first version of our clickstream system intentionally. The philosophy was, let's use every single Amazon service we possibly could, because it helped us get it built really quickly. And it was amazing. Like, we were able to get done super fast, and we're still trying to pluck some of that stuff out. So I would say, like, the tricky part is it's hard to change. It's hard to switch away from, the Amazon services. Like, so the ones I'm speaking of are like Kinesis and API Gateway. It's a pretty cool product that kind of gives you a nice solid endpoint that's not going to go down. So now we're replacing that with like a Go front end with, I think Kong is going to be involved in there somewhere, which I barely know what that is. As CEO, I'm a technical founder, but like, at this point, I don't get to have too much fun writing code. But yeah, I would say we're just plucking out the last of our dependencies on Amazon services, so that our entire platform just runs on plain old EC2 instances, and we're also making it so that it'll run on Google Cloud or Azure. But I'd say that's the biggest one. There's other things that you basically learn, and here, like, basically our strategy for pulling data off of the Kinesis stream worked for a period of time until it stopped working, and like the applications behind would start to get behind. So we just recently reorganized how, like, basically each destination that the data has to go to has its own dedicated service, whereas before we would have, like, we had the Redshift service, and then we had the everything else service, which worked fine for a while, but then eventually, you have to start just breaking things down into smaller and smaller pieces. I'd say that's we have a big reliance on S3 as well, and so we're actually trying to break that reliance, which will probably be the last thing we do. But it's pretty nice. S3 is obviously a really nice tool, so it's tough to not rely on things like that.
I think that's a reason that a lot of the other object store services have tried to replicate the S3 API as well, to try and ease the transition to their service, is because it's such a ubiquitous service. Even people who don't necessarily use EC2 will typically find S3 as their first entree into the Amazon Web Services morass.
Yeah, and our CTO, he tells me all the time, he tries to make me feel guilty. Like, every time we decide to pluck one of these things out, it means we're trying to build something that's as reliable, or similar to S3. So yeah, it's a lot of pressure. And so, I think it's, companies can get a lot done with just using the Amazon services. And I don't really have a huge problem with that, but, we're trying to build something. It can get expensive, we had a certain customer that was using what seemed like a pretty naive thing, and then they were using a ton of Lambda calls. Lambda is a really cool technology too from Amazon, but it isn't cheap. Once you get to a certain scale. So our own Amazon bill, I think, was approaching $15,000-$20,000 a month with all the stuff we have running on it. So it can get pretty pricey pretty quick when you go to scale. So it's I think it's worthwhile to try to not be completely tied to it.
from the platform perspective, are there any sort of dead ends or failures that you have encountered that you've had to sort of back out of or try to pivot around in the process of building out your platform?
Yeah, so even right now, like we've been working on a solution to use Spark streaming to process clickstream data off of Kinesis and get that data in microbatch form to Redshift. And that seems like a pretty simple process, but the way we were working it looked good on paper. Then we started pushing our production level volume to it, and the workers couldn't keep up with the stream. Even with Spark streaming and all that. So we were about ready to. We're like, I don't know if this is going to work. Finally, we just had a breakthrough this week to figure that stuff out. But the challenge is like not too many people know how. There are not very many Spark streaming experts. Period. That are working with it at scale. So, and a lot of times, it's a tricky thing. Is like we're basically building experts in all these technologies as we build the company. We've got a 20-person engineering team, and a lot of them are new to a lot of these technologies. So yeah, I'd say we often, especially as we have new people coming up, they do naive things and they figure things out, and we're building that competence. But I'd say that there are a lot of knobs and switches on like say Spark that we're learning what all those things do, and it's pretty hard to predict when tasks are going to be done. New features that we're working on. Pretty much have to just like leave some of these things open-ended, which is pretty frustrating as a founder and trying to deliver features to customers. But this stuff's pretty tough.
There's some areas of data engineering as a whole and the overall workflow that are very well defined and have a number of tools to choose from, such as Airflow or Luigi or Oozie for being able to do workflow management, or things like Spark and Flink for doing streaming data. But there are other areas that seem to have just complete gaps, such as the ability to track provenance of data or anything like that. So I'm wondering if there are any particular holes that you're experiencing that you see opportunity for building new tools to add into the sort of ecosystem of data engineering.
Well, I think the one that we're contributing is this idea of basically having a easy way to access best practices that you don't get it from, you really can't. It's a tricky thing because like you can't find out the best way to get Salesforce data into Redshift from either. It could be that Salesforce wrote a guide for that, or it could be that Amazon Redshift wrote a guide, and that's like the kind of the most common integration. But from there, it's a very big universe of potential combinations that most people haven't written anything about. So, like I said earlier, it's tricky to have to always be starting from scratch. A lot of times, junior developers get thrown on these kind of projects and kind of make a mess of it. So we're very inspired by like what Ruby on Rails did for web development and what Node did. And I know you're a Python guy, so Django was a part of that story as well. But there's in other areas of software development, we have these awesome libraries that help us get simple things done really quickly. And I think that essentially the infrastructure tools are coming together. I think it's these higher level functions that you're kind of on your own. Like just talk like cleaning data, or for example, like we help companies get their Twitter data, Twitter ads, Facebook ads, and LinkedIn ads data kind of all talking together in the same format. That's like it's a shame to me that there are so many devs out there working on that exact same problem at the same time that we are, and we're not collaborating on it. So I think open source collaboration of methods of higher level tasks is definitely an open area that we're excited about.
Yeah, it's definitely interesting to see how open source has become much more of a sort of standard operating procedure for companies as its overall visibility and idea has become more popular, whereas back 10, 15 years ago, open source was something that, those hippie software developers do it, but it's not something for a big, serious company to get involved in. And now, if you're a serious organization, you're starting out right now, if you don't use open source and contribute back to it, then, you're the outlier. And the overall perception of open source as a force multiplier is becoming more popular because it gets people to buy into your platform and, make sure that other people's ideas are being considered so that you're not necessarily getting stuck in your own echo chamber and not understanding the actual real world use cases of whatever it is that you're trying to build.
Yeah, totally. And I think it's still like I talked to somebody the other day. He's like, I can do everything your platform does with SQL Server integration services. I'm like, okay, that's fine. Bye-bye. And there's still those people that are stuck on Microsoft technologies and they don't want to leave it. And that's fine. But for us, like I left Microsoft back in 2006 was the last time I ever wrote anything in Visual Basic or C#, I think had just come out. But, I think that there's definitely a lot of that still. We've got customers that still have, mainframes and mini computers and AS400s and all this kind of stuff. So, those technologies aren't going away anytime soon. But if you're doing data engineering work, the tools are just amazing. Like Airflow. I just explain to people, like, you don't have to put all your jobs on a timeline where you hope one thing finishes before the next thing starts. Everyone who's done DevOps, and I don't know, do you have any jobs that are scheduled like that? It's a very nerve-wracking thing, and it's just old school. Like Airflow solves that. So very lightweight, it's easy to use, like use it, right? But you have to use modern technologies to get the modern ideas.
Yeah, no, the ability to have event-based actions is definitely a vast improvement over, like you said, just having time-based and hoping things finish, or relying on the fact that, this happens at the same time every day, but then one day it doesn't happen. And so then you have to go in and manually figure out why not and what to do about it. So it's one of the reasons that SaltStack is my preferred platform for doing infrastructure automation, is because it does have that event-driven core, so it makes it much easier to be able to be reactive rather than sort of trying to predict the state of things at a particular point in time and then take an action based on that supposed state.
Yeah, I'm not super familiar with SaltStack. Can you tell me real quick what that does? And I think I saw you had a blog post about it, but I didn't read the blog post yet.
Sure. SaltStack is, at one level, it's a configuration management tool in the same ilk as Ansible and Chef and Puppet, but at another level, it's a framework for cloud automation. So it has an event-driven nature. The entire core of the system is an event bus, and so you can consume those events and then create reactors that will trigger based on certain event matches. You can also use it for distributed command and control, where you will send a command to a fleet of servers based on a particular set of attributes for targeting. It has the ability to interact with the cloud providers directly, so you can spin up infrastructure and tear down infrastructure. It contains a lot of primitives for being able to do essentially whatever you want. But again, as you mentioned before, the higher level capabilities of it, where you just have sort of a high level API of, do this thing and it will handle all the orchestration. They're still working on building up to that point. So as an individual, you can create those orchestration patterns and, create your own high level APIs, but the tool itself is much more at the low level, framework. Here are all the bits and pieces, go ahead and put it together.
Yeah. Well, it's got to start there, So I think it's it's a really exciting time, I think, to be a data engineer. There's so much stuff going on. I think, and it's going to just go from here. The thing we talk about a lot with our customers is the fact that we really believe that we're in the early stages of a data revolution. That think about like. What percentage of companies have modern machine learning running algorithms in their company? It's like less than 1%. Most companies can barely get a BI, get a chart that works, that's correct, and all that kind of stuff. So I think we have a huge. There'll be a long run for this stuff that we're working on over the next 20 years. As general and limited AIs start to come aboard. They're so data hungry. You got to get data from all these places into the right format, and so we're pretty excited about the space.
Yeah, my particular organization, we're sort of coming up to that same set of challenges where we actually just recently stood up our first business intelligence dashboard using Redash, and so we're starting to populate that, and we're starting to try and plan out having more of a sort of cohesive reporting capability. And so one of the things that's on my plate to start thinking about is building up an overall sort of approach to data management. And so I'm definitely keeping an eye on the horizon for things that are coming along, and keeping an eye out for the available tools and technologies to start stitching together. And also the other interesting piece of data engineering is sourcing the data and figuring out, okay, what are all the information avenues that I have, what can I consume, what can I aggregate together, what are the little hidden pools of data within the organization, because that can be, invaluable, where you have a picture but it's missing that one piece, and somebody in a different department just happens to have an Excel file that has all the critical data that stitches everything together, that you need to actually go and interview people and understand where that data exists.
Yeah, and that's like we were meeting with an insurance company the other day, and they have a person who pulls data from some raw sources, probably gets CSVs, pulls it into Microsoft Access, to do some additional manipulation to power his Excel report. And I'm just like, wow, like that Access data could be useful to other people in the organization, but there's no way they're going to get to it or use it. And so that's where we think like professional data engineering layer inside the company can tear down those ad hoc processes, make every Excel spreadsheet a little bit simpler. But it's a long journey. Like that's the thing we talk to our customers about. Like at first, like anything, like any new endeavor, like there's going to be false starts, and you're going to just run into roadblock after roadblock. But think about the value of having a single pool of fresh, clean data, and how that can impact your company. And the only investment there is you have to hire a few developers to go on that journey and make it better. So I think it's I think it's a tough thing to do by yourself for sure. So I hope you'll have some help in what you're working on there.
Yeah, absolutely. Yeah, and from what you were saying there, as far as unifying the availability of data across departments, it reminds me a lot of sort of the ethos of the DevOps movement of trying to break down silos and collaborate across all units in the business in order to act as a force multiplier, rather than having each of the different pieces working alone and not necessarily having all the broad open communication channels. So I definitely see a lot of parallels between the idea of data engineering and the movement that it's building up to, and the DevOps movement and what it has been trying to carry forward over the past few years.
Yeah, I can definitely see the analogies as well.
And so as a platform where you're working with a lot of other people's data and helping them to make sense of it, I'm sure that you've seen a lot of sort of curious use cases and scenarios. I'm wondering, what are some of the most interesting or unexpected uses of your platform that you're aware of?
Well, I'd say there was one potential one that didn't happen yet, or maybe it will happen. We'll see. And then we did a project for an insurance company where we were consuming NOAA weather data. And interestingly enough, like the data comes in as raster files, so essentially bitmaps and we had to turn that into actually like geospatial data. So I don't know, that one was kind of an interesting. I always think of data as files with numbers in it and not pictures. But obviously they can be pictures, but it's actually a really convenient compression tool, I guess, for the weather data to be pictures, which I guess makes sense. But I don't know. I've just been living in this world where that hasn't been the case. Kind of getting exposed to just different ways, different ways people are using compression. Another really interesting one for me that didn't come to pass, but almost got this one, was basically if you think about an ETL platform. So think about like Informatica or SnapLogic or any of these kind of tools. They are doing work and they create metadata. And so we actually had a customer who is basically a data provenance sort of a product, and wanted us to build ETL essentially from the ETL tools into a central repository. So it felt really meta that we would essentially be consuming data from some of our older school competitors as the data source. And I was like, I don't even know how this would look so weird on the website. If I'm like, oh yeah, Informatica is a data source for astronomer. But luckily, I mean, I didn't even know if I wanted to do that project because it would have been all brand new sources. But we basically do these projects where basically hard to get data is sort of what we thrive on. So that would definitely have been some hard to get data that if they have an API, we can get the data out of it. But it definitely would have been a weird one for us.
And as we talk some more and mention the name of your company, I realized that I've forgotten to ask where it actually comes from.
Oh, the name? Yeah. So originally it was a name. We were actually, it started as a tool in the Meteor ecosystem. So Meteor is a JavaScript framework for building web applications. But the way I explain it these days is, actually astronomy was sort of the first science that kind of moved us towards, facts over dogma. So, we like to think of astronomy as, you're studying something and you're doing some math and then you try to make some prediction for what's going to happen in the future. So we actually think that astronomy and data science, I mean, I'd say astronomy is a very early form of data science. So, we think it's a kind of a cool differentiating name that kind of sort of makes sense for the space.
Yeah. And also in my other podcast, I've spoken to a few astronomers, and the amount of data that they're dealing with on a daily basis is, excuse the pun, but astronomical.
Yeah, it really is, so, and the fun thing is like those people used to have to do all this stuff without machines to do the math. So they have these people that their job title was computer, and all they did was math problems all night long. And so luckily we've got real computers now to do that. Computer machines. So, but yeah, I don't know, it's been fun. Like we've actually learned a lot more about kind of the history of astronomy, and ironically, because of the name of our company, we've attracted amateur astronomers to the company. So it's kind of a very weird virtuous cycle where the more we talk about astronomy, the more people we attract that are into that sort of stuff. So, but yeah, it's kind of a little hobby for a lot of the people in the company at this point.
Are there any topics that we didn't cover that you would like to talk about before we start to close out the show?
No, not really. I mean, I think we covered a lot of the important areas. I'm curious, to see where the tools take us. I'm like I said, I'm very excited for the potential for what comes next, and I just think that this space is very exciting, and we're looking forward to being part of it for a long time.
Well, with that, I'll have you add your preferred contact information to the show notes so that anybody who's listening who wants to get in touch or follow what you're up to will be able to do that.
Oh, yeah. Okay.
And with that, I would like to thank you very much for taking the time out of your day to tell me more about the work you're doing with Astronomer. It's definitely an interesting platform, and one that I plan to keep an eye on, and maybe at some point in the not too distant future, I'll be actually taking advantage of it on my own.
Yeah, that'd be cool.